This is, I mean, didn't you guys do this in like trig or whatever?
No.
Oh, is that a cosine?
You just add them together,
Oh.
right? So this, yeah, this looks like cosine, right?
Yeah.
And then you just add them at the different points. So for example, at time 0, for this curve, what is the value of y? Yeah, so it's kind of like if we do x and y like this, it's 0, 2, 1, 2, 3, and 4. And what is it? So then you guess at 4, we can see it's 0, right? And now it's just a matter of whatever, guessing. Like maybe this is 1, this is 2, this is 3, this is 4. By looking, I'm thinking, I don't know, you could do like a ruler if you wanted to measure it out. Yeah, that actually comes out to be a little less than 1. So this one is about like 0.75. This one is like say 1.5. This is like say 1.75. So if we just,
Oh wait, no, never mind. I get it.
I don't think those are exactly right, but whatever. It's just approximate, right? So then you just add those to these. So let's do this in this purpley color here. Can you see this?
Yes.
No, okay, they can't see it. So how about this? Okay. So at time 0, I add a 2. So I start there. At time 1, I add 1.75. At 0, so I go 1 to 0.75. So it's like this one. At 2, I add a 1.5. So here's 2, and this is -1. So then this is 1 and then 0.75. So it goes to there. At 3, I add 0.75. Here's 3. There's 1. So I'm again around 0.75. Actually, that needs to be a little taller. So a little bit taller there. And then at 4, I'm at 0. So I add 0. So then it goes like this.
That don't make sense.
You just add up the numbers. That's it. And then connect the dots. So take a look at this. What did this curve, kind of pretend like this was the original. And then it moved into this. So what did you have to do to this line to make it look like that? Yeah, just shove it up. Do you see what we did? Just push it up. And do you see that the farther, or the closer you are to 0, the more you push it? Does that make sense? Use that logic on here and everything makes sense. Just push it up. And the closer you are to 0, the more effect you have. So that's why this is the biggest, and it goes down to there. Yeah.
Is the line picture proportional? Like, are they supposed to have the same dip, or like, because that dip is more shallow than the other one?
Yeah, and it's because this value goes into the negatives, but this is all positive. So what it does is it multiplies the positives, but it reduces the effect of the negatives. So that's why this dip is less than this dip. So the negative part got diminished, but the positive part got magnified. So it's like if you kind of like bump up the mountains and fill in the valleys at the same time. So you see that's what we did? We bumped up the mountain and filled in the valley. Now this one of course stayed the same, but that's because our value at 4 was 0. Any other questions on this one? Questions? Questions? Look it up.
No, stop it.
Whoops.